Hi everyone. So if you want to get started playing with Clonos, you can simply come to our homepage, go to the try it out tab, and here you'll find the actual system, a link to the actual system if you want to hack on it a little bit, an implementation of a Clonos runner for Beam, though this was mostly used for experiments using the Nextmark benchmarks. But what I want to draw your attention to is the test scripts repository. If you clone that, you'll end up with something like this on your local machine. And to launch a quick experiment, you can just launch this script with no arguments. This script will launch Docker containers with Clonos. So you need Docker and Docker Compose on your machine. And it will also automatically launch HDFS. If you want, you can also go inside the script and alter one variable, and it will also use Kafka to push the data in and out, which will allow you to do finer grained measurements even on your local machine. Now, this job is creating those containers. This script is creating those containers. It is pushing the Flink job or the Clonos job into the cluster, and soon enough we'll see the job show up here. Even though it's a job with a depth of 3, it will actually consume all 6 task managers, because 3 will be used for the main job, and another 3 will be used to create standbys for the main job. So you can see that just happened. Now, opening up the job, you'll see it will start consuming data, and soon enough, in about 20 seconds, we'll see that the map task will be killed by the script. And this map task will be automatically replaced by one of the standbys, which will initiate the recovery protocol to achieve a consistent recovery. Now, the script I was telling you, which we just launched, is here. You can find all these variables are things you can change. Oh, sorry, so the task was just killed and replaced automatically. Throughput is still good, and so we're happy with that. Now, the two more complex variables here are the local experiment, which if you change to false, you must specify the locations of the Kubernetes services that the script expects. But all the rest should work automatically after you configure these. And also the graph only, which will essentially allow you to use Kafka to push data into the cluster. To do that, you must use the distribution of Kafka, which we have included here, because we've modified it to generate the data that this particular synthetic job expects. Now that the experiment is done, you'll see that there's a results folder. So if we go into that results folder, and because there was only a single actual experiment done here, we just follow the experiment 0 link. You'll find some information here on the root directory. For this experiment, it's just throughput. But if you use Kafka, you'll also see detailed end-to-end latency. But I want to draw your attention to the logs directory, where you'll find logs for all the workers. In particular, worker 10 was the one that we killed and had to recover. So if we open this up and we zoom into that, we'll be able to see that this is the task that started in standby state. Then it received the start recovery notification from the job manager, at which point it transformed its input channels, connecting itself to the data flow. It requested, let's see, where is that? It sent out an in-flight log request to replay the inputs. It sent out determinant requests. When it received all those determinant requests, it recognized that it had all the determinants needed. In this case, it knows that it has a main thread log with 749 bytes of information in it, which is encoded here. And it also has a channel log for a particular intermediate dataset and subpartition, which is very small in this case. Now it replayed through all that and finished recovery. in this case, let's see, in about 100 milliseconds here. And then just became a normal task. It started doing checkpoints completed, and recovery is established with exactly one's consistency. So if you want to play around with Clonos, I hope this helps. Thank you.